I am going to talk about the main strategy for the math section, which in a couple ways parallels the main strategy for the reading section, which I encouraged you to use dumb summaries. Basically, we don't have the time to look at every single detail in a passage, so it's much better to just simplify things. Ignore the details as much as possible, start from simpler, dumber places, and then let the question build on from there. And the main way that we talked about that is to use connotations to think about the passage in a very simple way at first, right? Are they using a lot of positive words, a lot of negative words? If they're using a lot of positive words, then we would expect the answer choice to also have some positive words as well, right? There's a symmetry there. So in the same way, the main math strategy is also about dumbing down the question, simplifying it, removing details, and plug points into equations is about as simple as it comes, okay? It doesn't have a fancy name, this strategy, because I don't want it to be confusing. I want it to be straightforward. Take points that you're given and plug them into the equations. And so we can think about all sorts of different types of math questions in this exact same way. Rather than deal with a million different types of solutions for the wide variety of questions that we're going to see, we can start from the same place for every question. Are there points? Are there equations? Sometimes there will be both, and you just plug them in and that's that. Other times, as we'll see, there might just be one of the two, and that doesn't mean that we can't use this strategy. It just is a reminder that maybe we can get points from somewhere else. We can be clever about it, or we need to use our memory and use equations that we've memorized, like the average formula or y equals mx plus b. So I'll show you some examples of this and how we can use the strategy to keep things centered, but basically that's what it is. Plug points into equations is an excellent way to frame every math question the same way, so that we're starting from the same place. And if you're not good at math and dealing with all the wide variety of situations you might see, this is a really great way to just stay centered on one idea throughout the entire test. So let's start with a very straightforward example of what this would be, okay? The graph of the linear function f in the xy plane contains the points 0, negative 10, and 8, 38. Which equation defines f where y equals x? So this is some pretty standard stuff. They want us to build a linear equation. So the first thing I would notice is I've got a bunch of equations in the answer choices. So remember, answer choices are just as much a part of the question as the question itself. So we can't ignore those. So that's where I'm getting my equations. And then I see some points, so I'm just going to pick one of them. Let's do the simple one, 0, negative 10, right? 0 is a nice, easy number. And basically what I would do is just go down the line of the answer choices and substitute 0 in for all of the x's and hope that I got negative 10 as the y. So some of you are going to set this up a little differently, but the way I do it is, since the left side of the equation, the f of x, is very straightforward, I'm just going to leave that aside for now and focus on the part that has all the stuff going on, and that involves the x. So I've put 0 in for x, 8 times 0 is 0, 0 minus 10 is negative 10, and negative 10 then is the f of x, is the y that I was supposed to get. So it checks out, great. But I need to test every single answer choice. If we have multiple equations or multiple points, then we need to try everything, because sometimes multiple answers will work. And so sure enough, if we go to choice B and do the same exact thing, 6 times 0 is 0, 0 minus 10 is negative 10, so that also gives us what we want. Let's just do it for the other two choices. If we do C, we can see that we actually get 86, which is a different y coordinate than we would want, so that must be wrong. We can cross that out. Same thing happens in D. We get negative 90, different number, so that's wrong. So at the very least, just by plugging this point in, we were able to eliminate two answer choices. So from here, I would just recognize, well, I did the first point, and it got rid of two answer choices, so maybe if I do the second point, 838, I'll be able to get down to one answer. And now, since I've already eliminated C and D, I just need to do A and B. And so if I put 8, my new x coordinate, in for the x in the equations, I see that only choice B gives me the y coordinate I want, right? So 8 times 8 is 64, minus 10, that's 54, but I want it to be 38, and sure enough, in choice B, 6 times 8 is 48, minus 10 is 38. That's exactly what I want. So look, this is, in my opinion, the best way to show you what plug points into equations feels like, looks like. We have both things. It's very obvious we have both things. And the work is going to look like this. And remember, on the digital SAT, we don't have a way to write on the question itself. So we're going to have scrap paper, and we're going to have to write this out. So I think this is a very comprehensive way of sorting through all this information so that we don't make a careless mistake. But some of you might be looking at this and saying, well, I could have done this much more easily. I know how y equals mx plus b works, and that's what these equations are. They're equations of lines. So you might be thinking, well, I can find the slope of the line. There is a formula for that, and then I can find the y-intercept. Great, I'm happy for you. Those things might be a little faster here. I do worry about them in certain ways. For example, the slope formula, which we can use when we have 2 points that lie on a line. We can use the slope formula to find the slope between them, which would then be the m portion of y equals mx plus b. Well, that's a formula that's got some risk involved, right? It's easy to confuse the y's and the x's and put them in the wrong place. It's got negatives built into it, and then we've got negatives in the points, so there's some kind of chance we might lose a negative there. And so it's a risky formula, and maybe it's only a 3% chance that you mess it up, but to me that's kind of high. Same thing with y equals mx plus b, thinking about the b portion, the y-intercept, right? We can see from the points that we're given, hopefully, that 0, -10 is a y-intercept. And then that should appear as this little last add-on piece of the equation. So only a and b would make sense right from the start, just thinking about the point 0, -10. These are all valid ways to get this answer. But I hope you recognize the difference between those ways of solving it and the way that I chose, the plug points into equations way. With the thinking about y equals mx plus b or the slope formula, we're doing a lot of algebra. We're thinking about math conceptually, sometimes a little abstractly. And that's where errors tend to creep in, when we are thinking about math instead of doing math, right? And that's what my work shows. That's what math looks like when we're actually doing it. We have numbers, we're using PEMDAS to work them through and simplify things. There's no variables anymore, right? So it's a little bit safer. And I certainly think as you go through a section and you encounter more and more of the tricky questions, you're going to want to shift your strategy more and more to plug points into equations and try to avoid that conceptual thinking that can get us in trouble. So let me show you an example of why I think conceptually it's risky to think about formulas and not do math and think about it instead. So here's a question. I'll just read the question part. We got an equation to start. The function f is defined above. The y-intercept of the graph of y equals f of x in the xy plane can be written as 0k, where k is a constant. What is the value of k? So for some of you who don't like math very much, this might just sound like a different language, okay? So I get that. This is a lot of extra stuff. But when I read this, I only really see two things. I'm given an equation, I'm given a point. So my dumb summary math strategy brain is just, well, points and equations, plug points into equations. So I'm definitely going to do that. Even if they hadn't said the point 0k a coordinate, we still should know that they're giving us a point, or at least they're talking about a point. Anytime they use the phrase y-intercept or x-intercept, we have to immediately think, oh, they're giving me a point, or at least half of one, right? If it's a y-intercept, we know the x-coordinate is always 0. If it's an x-intercept, the y-coordinate is always 0. This is something you need to memorize, and it does work with the plug points into equation strategy. There's no way around it. The SAT loves intercepts. We're going to use them a lot, so we need to understand it in that way. Now, if you're thinking about this equation conceptually, you might be like, oh, it reminds me of y equals mx plus b, which we talked about in the last question, right? So the b was the y-intercept, that's the part at the end, and so -1 is the part at the end, so that must be the y-intercept. No, that is a trap. That is not what's going on here, okay? That's what they want you to think is happening, but that's what happens when we just think conceptually about math, is we fall for these traps. And so you might be like, oh, okay, it's not y equals mx plus b. I can see it because the x is actually an exponent. So that's different, right? A line doesn't have an exponent. So the x is there, that's an exponential equation. And I know how those work, right? So those, the number in front of everything, that's the y-intercept. So the y-intercept in this case is 9. No, that's also a trap. This is a classic example of how the SAT makes things hard. They take stuff that kind of works with what you've learned in school, that looks a little familiar, but they twist it up in slight ways, hoping that either you're not smart enough to notice or you're just too lazy to notice, and that's where we get in trouble. So if you pick A or C here, it's because you're thinking about math and not doing math. But doing math here is so simple. We have a point, we have an equation, plug the point into the equation. And when we do that, right, the x coordinate is 0. So I put that in there in the exponent. And then k represents the y. So I replace that with the f of x. So now it's just a matter of simplifying. 2 times 0 is 0. So our exponent is actually 0. 4 to the 0 is 1, right? Remember that any number to the 0 power is 1. That's an identity that we need to know. 9 times 1 is 9, and 9 minus 1 is 8. So 8 is the answer. That is doing math, okay? That is how we avoid traps. And if we do that and we just do all the arithmetic right, then we recognize that we didn't even think of A and C as potential answers, right? They weren't even traps for us. The math just proved the answer definitively. And that's really what we need to think about with the SAT. Again, they're going to twist things up in ways that are subtle, and we have to be ahead of the game and make sure that we're not falling for those traps. Plug points into equations gives us a way to come back to arithmetic, which is the kind of math our brain really likes. It's got numbers, it's got solving. Algebra is risky. Conceptually thinking about formulas is risky, right? If you are not writing something on your scrap paper for a math question, you should sense that maybe you are falling for a trap, okay? Plug points into equations is a way to just keep bringing us back to very simple stuff. And notice it didn't really matter all the other math jargon that came up through in this question, right? K is a constant, it's in the XY plane, F is defined above. All this stuff doesn't really matter for us solving the question. It's just there to make you scared. And so plug points into equations is another way of just being like, ignore those details. We have a point, we have an equation, plug it in and see what happens. Let's look at a slightly different example where things get a little bit more complicated, okay? So in this case, it's obvious that I have equations, right? The answer choices are a bunch of equations. Technically, they're inequalities, which does add a little bit of a complexity, but I think of it the same way, right? I have something I can plug numbers into, but I'm not given any points, at least not in the same way I was on the previous questions, right? So how am I going to use this strategy? Well, the real way to use it is that it always gets us to ask the same two questions at the start of every question, right? We say, do I have points? Do I have equations? Yes, I have equations. I don't have points, but maybe I can get them from somewhere, right? So now I have a task, a goal. And luckily, whenever we have a graph, we're pretty much always being given points. So normally I would take some points off of the line itself, but because this is an inequality, I'm going to move away from the line. I'm going to go to the shaded region because I see in my answer choices that it's a greater than or less than or equal to sign. So that it's not going to help me basically. So go into the shaded region and I'm just going to randomly pick a point. I'm going to pick the point 0, -2. I like that there's a 0. It's in the shaded region. I'm just going to pick it. And then I'm going to do exactly what I've been doing, right? Let's go through each choice and let's just put 0 in for all the X's. -2 is in there for all the Y's, right? I didn't rearrange anything. There's no algebra here. And I used parentheses because I'm afraid of losing negatives. I can tell from the answer choices that if I lose a negative, I'm going to get this wrong. So I'm being really careful. And then when I simplify the left side of each inequality, I can tell whether it's an inequality that makes sense. And only choices A and D give me things that make sense, right? 2 is greater than or equal to 0. That is true. Whereas choices B and C, we can see are wrong because 2 is not less than or equal to 0 in B, and -2 is not greater than or equal to 0 in C. So just like we've been doing, we can get rid of some choices pretty easily. Now, what did we do before when we had a couple answers left? Well, we picked another point. So in this case, I go maybe now to the x-axis, change it up a bit. I'm picking still a 0. I'm changing it to -3 so I don't confuse where I'm plugging things in. I'm always afraid I might plug in the wrong place. But now I'm just trying choices A and D, and the same thing happens, right? I plug in -3 as my x coordinate, 0 is my y. I simplify, I keep track of my negatives, and only choice D produces a valid inequality, right? -3 is not greater than 0, so A is wrong, but 3 is greater than 0, so D is right. And that's it, that's the whole thing. Now, maybe we could have done this algebraically by taking each of those equations and rearranging them into y equals mx plus b form, and then comparing the slope and all that stuff, and thinking about the inequality and the direction. But again, those negatives there, I can tell if I lose a negative, that's game over. And negatives and inequalities interact in really annoying ways. So there's just so much more risk thinking about this algebraically. I would rather just let the numbers prove the answer. It's so much better to just see your work, prove your answer, then you're confident you can move on. Maybe it's a little bit longer sometimes to solve things, but if it means making fewer careless mistakes and falling for fewer traps, that's a net improvement to your score. And let me show you one last question where I think this strategy really shines, okay? Here's a story question. Let me read it. A car rental service charges $120 for the first 3 days of a car rental. For each additional day of the car rental, the rental service charges a daily fee. Renting a car from this service for 8 days has a total cost of $370. Which function C gives the total cost in dollars for a car rental lasting D days where D is greater than or equal to 3? So some of you tuned out at the beginning there because you hate stuff like this, right? It's crazy. How do we come up with anything? Well, again, I'm just thinking of this in a very simple way, right? My strategy is plug points into equations. Do I have points? Do I have equations? Well, once again, it's obvious that I have equations. That's what the answer choices are. So I'm asking the deeper question, do I have points? Well, points are just collections of numbers, and I can see I've definitely got that, right? Look at the end there. There's 8 days, costs $370. That's a point, right? Now, they don't use X and Y. They use D kind of as like an X coordinate and C as a Y. And so we just need to match the number to the right letter, right? So 8 days, the units really help us here, is my X, and 370 is like my Y. So this ends up being exactly the same as the other question, just plug points into equations here, right? So again, if we do it for every choice, 8 is my X, it's going in that place, and I'm seeing, does it give me the right coordinate for Y? Choices A and C do, choices B and D do not. So now I'm at a 50-50 shot without really thinking about this in any way. And of course, well, I'd love to get down to one answer, so what do? I plugged in 1 point and I got rid of half the answers. Maybe if I plug in another point, I'll get rid of the other half. Is there another point? Well, there are 2 more numbers in the question. Why don't we think of those as a point, right? 3 days, $120, right? That's another point where X now is 3. So we plug that into A and C, and sure enough, only A works. And I'm confident that's the answer because my math proves it. This is so similar to the way that we think about reading, okay? Or I should say it better. This is very similar to how a lot of you think incorrectly about the reading, right? So what a lot of people do for the reading section is they get this passage and they read it, and maybe they have to read it twice, and they try to come up with a summary of the main idea, whatever it's about. And then they go looking for that summary in the answer choices, forgetting the most obvious thing here. These are multiple choice tests. The answer choices are summaries, right? Don't write your own summary and then look for it in the choices. Use the 4 summaries that they give you and test whether or not they make sense in the context of the passage. That's the main reading strategy, summaries. The same thing applies here, right? Rather than read this story, this passage, and write our own summary of it, our own equation that captures what's going on, we just realize that we're given 4 answer choices, 4 summaries of the story. So what we're doing is we're testing whether those summaries are accurate representations of what's going on. And the way to do that in math is to plug points into equations. It's so much easier. It's so much less psychologically demanding, right? We have willpower here. We can only be doing math for so long before our brain starts to turn to mush. And so this keeps it simple. Rather than trying to understand the story and get everything right in the right place, we end up just saying, I don't care why the equation works. I'm just going to test whether it works. And that's the thing, is I don't really look at choice A now and say, oh yeah, that's obvious. I should have known that was right. I mean, notice the number 50 does not appear in our story at all. The number -30 does not appear in the story at all. Why would the y-intercept be negative? That doesn't even make sense, but I don't care because the numbers proved it. I move on to the next question here. So let's just summarize all of this, right? The main reading strategy, like I said, is to simplify things. The main math is the same way. Simplify things, keep it as dumb as possible, and thinking only in terms of points and equations is a really helpful way to just give yourself less to think about. Now, it's not always going to work. Sometimes there are questions that there aren't points or equations. But a lot of times this is just a way to get the ball rolling, and especially if you see both points and equations, you can just start right away. If there's only one or the other, as we saw, we can often fill in the gap, either by getting points off of a graph, getting points out of a story, or sometimes we know certain equations like y equals mx plus b that we can bring into the question as needed. So there are places where we might not be given equations, but we're able to bring them in from our memory, and then we have points that we can plug into them. I hope this was helpful as a good start for thinking about the math in a new way. Even if you are very good at math, thinking about plug points into equations can really keep you centered on just a few ideas as you go through, because the SAT is going to have you bouncing around a lot. So plug points into equations keeps you centered, and that's what we want.